Hi, this is Suraj over here, and today's lecture is based on Introduction to Software Testing. So we're going to take a look at the outcomes now. So we're going to take a look at concept of software faults, some of the sources of software faults, including example. We're going to take a look at a very simple definition of software testing, including the concept of verification and validation. Then we're going to cover the main principle of software testing, good test cases and successful test cases, and why do we need to test, and some of the main testing activities like generation of test plan. Well, to understand software faults, you need to understand that software faults may cause loss incurred by companies, and maybe loss of life and loss of confidence of stakeholders. Okay, it may be your end users, or it may be the company itself, right? So software faults may be small bug, maybe an infinite loop that may cause one of your functional requirement to function improperly. Okay, so software faults is all about loss. Now, some of the sources of faults. So one of the main criteria of building software is the requirement specification, or the software requirement specification document known as the SRS. So if you have an improper requirement engineering that has taken place, therefore it's obvious that you're going to have some sources of faults that will be happening in between the different stages of SDLC. So maybe faults also in design after there has been any proper requirement engineering. And obviously, if there is presence of fault, there must be obviously inadequate testing procedures that has been carried out. Now, there can be also evolution of software whereby new features are added to introduce new faults. Maybe changing of one component or one module of the whole system may generate bugs in other modules. It depends whether they are strongly coupled or loosely coupled. When it comes to software testing, if we want to give a perfect definition of software testing is just a set of activities where you try to prove the quality of your product to stakeholders. When I say quality of the product, it means that it meets the user's requirement and also the right product has been designed. So in other words, verification and validation is part of testing. When it comes to verification, are we actually designing the product right? So let's say software X implements a certain functionality X, right? So how far software X is going to impose, or let's say implements a functionality X, right? Does a functionality X carried out by software X is actually verifiable, right? So it's all about functionality. And when it comes to validation, if you're going to consult Roger S. Pressman, so the definition is quite a bit confusing, but what you need to know is verification is about the functionalities, and whereby validation is about a traceable requirement that's going to go to the requirement traceability matrix, right? So validation is about the right product, making sure software provide traceable requirement. So some of the main principles of software testing is if you design a good test case, it's obviously going to find bugs. Successful test has to find undiscovered errors. So you may undergo one test, you may undergo a second test, and if the test is said to be successful, therefore new errors have been discovered. Now, testing can be destructive. That's obvious. Just assume that you're going to change one or two lines of a module. So this is going to change maybe the whole design of the system. Okay. So testing cannot find all defects, but we can find some of the defects that can be used to make the software of better quality. Now when it comes to testing and confidence, the more you test, the more bugs you find, and the more bugs you find, the higher is the percentage of confidence. Now some of the main standard testing activities. It starts by modeling the environment, and then you will need to decide upon the test cases, right? So select test scenarios, and then you're going to test and evaluate, and then you're going to measure testing progress. So let's start with modeling the environment. So first of all, you're going to select one of your interfaces that you're going to test. Okay, so interfaces may be component interfaces, or it may be GUI interfaces. Now select some test scenarios which you're going to use. Now test scenarios may be based on coverage of statement as a branch, or can be including it may include also path testing. You're going to test and then you're going to evaluate at last. So you test first and then you're going to evaluate. Now one of the main things that you must note here is when you say select test scenarios, you need to select appropriate test cases. Why? Because the more time you're going to test, the more time you're going to take to test, it's obviously the software development life cycle is going to be delayed, right? So select appropriate test cases, and most of the time you try to take upon coverage test cases. Then you just test and evaluate. Now you must measure the testing progress. Do we need more testing of this component or this module? Right? So in the next lecture we're going to take a look about how testing is applied to software life cycle. So testing is itself in itself is a separate has a separate testing life cycle that we're going to go through, and then we're going to evaluate the different stages and provide example about them. For now, take care.